Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss one of the gate question which came in the year 2015 related to scheduling algorithms. These kind of questions will help you to understand the concept in a better way. If you want to learn all the scheduling algorithms in a single video, then you should watch this video because in this video, I will discuss about first come first serve scheduling algorithm, shortest job first scheduling algorithm, shortest remaining time scheduling algorithm, and round robin also. So I request everyone to watch the complete video. First let me read out the question, then I will discuss the solution with you. Look at the question. For the process listed in the below table, which of the following algorithms will have lowest average turnaround time? They have given a table consists of process name, arrival time and burst time. Totally they have 4 processes, which is A, B, C and D. Now they have provided 4 options. 4 algorithms are there. First come first serve, non-preemptive shortest job first scheduling algorithm, shortest remaining time first, round robin with time quantum 2 units. Now if you use these 4 algorithms for the given table, which algorithm will have lowest average turnaround time, they are asking. So first we'll solve the first come first serve scheduling algorithm. Any scheduling algorithm will have 2 parameters. One is the criteria and another one is mode. The criteria for first come first serve scheduling algorithm is arrival time. Okay. And we have 2 types of scheduling algorithms. One is preemptive, another one is non-preemptive. First come first serve scheduling algorithm will come in the category called non-preemptive scheduling algorithm. Okay, with this knowledge, let me draw the Gantt chart for the given table using first come first serve scheduling algorithm. Always the Gantt chart will start at 0 units of time. We will have 7 states in a process data diagram, which is new, ready, running, terminated, wait, suspended wait and suspended ready. Out of the 7 states, we will use the ready state and running state to explain this concept. Okay, now if you look at the table, process A only arrived at 0 units of time. If process A only arrived, that will be scheduled to the running state. As process A needs 3 units of CPU, it is a non-preemptive scheduling algorithm. Process A will run for 3 units of time. After that, it will complete its task and go to the terminated state. By that time, only process B has arrived. Again, it will be dispatched to the running state. It needs CPU 6 units of time. It will be provided and it will complete its task at 9 units of time. By the time, if you look at the table, process C and process D has arrived. Now, which process has arrived first? Process C. It is a first come first serve scheduling algorithm. The process which has arrived first will be given high priority. So process C has arrived first, so it will be scheduled to the running state and it needs 4 units of CPU time. It will be given at 13 units of time. Process C will complete its task. Then process D will be scheduled. It needs only 2 units of CPU time. It will also be provided at 15 units of time. All the processes completed their tasks. Now, using this knowledge, we will compute the completion time and turnaround time. Now, if you look at this Gantt chart, you can say that at 3 units of time, process A has completed its task. At 9 units of time, process B has done 13 units and at 15 units. Okay. Now, we need to compute the turnaround time. How can we compute the turnaround time? Turnaround time is equal to completion time minus arrival time. So, 3 minus 0 is 3. 9 minus 1 is 8, 13 minus 4 is 9, 15 minus 6 is 9. Now we need to compute the average turnaround time. Average turnaround time is equal to sum of all the process turnaround time by number of process, which is 3 plus 8 plus 9 plus 9 by 4, which is equal to 18 plus 8, 26, 26 plus 3 is 29. 29 by 4, 7 4s are 28. So you will have 1 by 4 is 0.25. So first come first serve scheduling algorithm, we got the average turnaround time as 7.25. Now we will look at the non-preemptive shortest job first scheduling algorithm. Okay, again we will look at the criteria and mode. Let me write it as SJF shortcut. The criteria is burst time. The process which has the less burst time will be given high priority. And the mode, if you look at the option here, they clearly mentioned as non-preemptive. So it is a non-preemptive scheduling algorithm. With this knowledge, let me draw the Gantt chart. Again, the Gantt chart will start from 0 units of time. Again, we need to look at the ready state and running state. Okay, at 0 units of time, process A only arrived and it needs 3 units of CPU time, it will be given. So at 3 units of time, process A has completed the task and gone to the terminated state. By the time, process B has arrived to the ready state at 1 unit of time. So there is no computation, it will be dispatched to the running state. It needs 6 units of CPU time, that also will be provided, and at 9 units of time process B has completed its task. See, here they did not mention anything about the IO request or IO completion time, so that's why we are not sending the any process to the wait state. Okay, now look at the time. At 9 units of time, by the time process C has arrived and process D has arrived. Now what we need to look at, we need to look at the burst time. Look at the burst time. Process C has 4 units of time, process D has 2 units of time. Which process has the lowest burst time? Process D. That will be dispatched to the running state and will be provided 2 units of time. At 11 units of time, process D has done. Now only one process is there, C. It will be dispatched and it will be run for 4 units of time. Okay, process C will complete its task at 15 units of time. So with this Gantt chart, we can easily compute the completion time, turnaround time and average turnaround time. Completion time of A is 3, B is 9, D is 11, C is 15. Now, if you compute the turnaround time, how can you compute the turnaround time? Completion time minus arrival time. 3, 8, 9, okay, it is 9, sorry, it is 11, okay, 15 minus 4 is 11, 11 minus 6 is 5. Are you able to understand? Or you can take 6 plus 5 is 11, 4 plus 11 is 15. Okay, now we need to compute the average turnaround time. Average turnaround time is 3 plus 8 plus 11 plus 5 by 4. Is it clear? Now if you look at what is it, 3 plus 8 is 11, 11 plus 11 is 22, 22 plus 5 is 27, 27 by 4. Okay, 4 6 are 24. You will have 3, 3 by 4 is 0.75. So for SJF, you got, okay, 6.75. Keep it that information. Now we will discuss the shortest remaining time for scheduling algorithm. Shortest remaining time for scheduling algorithm, I will write it as shortcut as SRTF. The criteria is burst time, BT I will write, and mode is preemptive. See, you can say it as a shortest remaining time first, or you can say that preemptive shortest job first scheduling algorithm. Both the names are same. Okay, so with this knowledge, let me draw the Gantt chart, and we will have a ready state and we will have the running state. Now at 0 units of time, process A has arrived and it will be scheduled to the running state. Now it needs 3 units of time, but however we will run for only 1 unit of time, because by the time process B has arrived to the ready state. Now you need to look at the burst time of process B. Process B needs 6 units of time. Process A needs another 2 units of time because it has completed for 1 unit of time. Now what is the criteria? Burst time, meaning is that the process which has the lowest burst time will be given high priority. Among A and B, A has the less burst time, so it will be run. So A will be run for 2 more units, because if you run for 1 unit, again it will be 1, which is lesser than the B's burst time. So we'll run for 2 units. At 3 units of time, process A has completed its task. Whether process C and process D has arrived? No, they did not arrive. So only one process is there, so which will be dispatched to the running state. And it needs 6 units of time. Out of that one, what we will do, we will solve for 1 unit of time, because by that time process C has arrived. At 4 units of time, process C is arrived, and it needs only 4 units of time. Out of 6 units of time, 1 unit of time is service is provided, so it needs another 5 units of time. Now which process has the lowest burst time? Process C. So there will be a context switching. Okay, so process C will come into the running state, process B will be sent to the ready state. Now what is the remaining burst time? Process B 5, C is 4. Okay, now next process, when it will come at 6 units, so till that time process C only will have the less burst time, so I can run the process C till the 6 units of time. So we have served the process C for 2 units of time. I did not serve, CPU has served, so its remaining burst time is 2 units. Okay, keep that information. By that time process D has arrived, and it also needs 2 units of burst time. Then if you look at the criteria, process C and process D also have the less burst time. There is a tie. If there is a tie in the burst time, then we will look at the arrival time. Among the C and D, which process has arrived first? Process C has arrived first, so it will be given high priority. So again process C will run for 2 more units. If you say 1 unit, again 1 unit will be there, which is lesser than the burst time of process C is less than the process D. So you can run for 2 units of time and complete the task of process C. Process A and process C are done, they went to the terminated state. Now process D and process B is there. Which one has the lowest burst time? Process D. So which will be given high priority to schedule to the running state, and it needs only 2 units of time. We will run it. Then process B will be scheduled. It will be run for 5 units. So at 15 units of time, all the process has completed their tasks. Now with this knowledge, we can find the completion time, turnaround time, and average turnaround time. Process A is completed at 3 units of time. Process B at 15 units of time. Process C 8 units of time. Process D 10 units of time. Now turnaround time, how can you complete? Completion time minus arrival time. So 3 minus 0 is 3. 15 minus 1 is 14. 8 minus 4 is 4. 10 minus 6 is 4. We need to compute the average turnaround time. Average turnaround time is 3 plus 14 plus 4 plus 4 by 4, which is 3 plus 14 is 17. 17 plus 8 is 25. Am I right? 3 plus 4, 17. 17 plus 4 is 21. 21 plus 4 is 25. 25 by 4 is 6.25. Because 4 6 are 24, you will have remainder 1. 1 by 4 is 0.25. Okay, let me write it as shortest remaining time first, has 6.25. Till now SRTF is the lowest turnaround time. Now we will look at the round robin scheduling algorithm with time quantum 2 units, RR. The mode is preemptive. Okay, is it clear? Now because it is a time quantum is given after particular time units of time, the process which is there in the running state will be sent to the ready state. Okay, so to make you understand this concept, I will use the 2 states or 2 queues, ready queue and running queue, or you can say that ready state and running state. Okay, now if you look at the Gantt chart, it will always start from 0 units of time. At 0 units of time, process A has arrived to the ready state. Only one process is there that will be scheduled to the running queue. It will be run for 2 units of time. You can ask me why it is running for 2 units of time, because the time quantum is provided 2 units. So it will be run for 2 units. Its remaining burst time is 1. Then what will happen? By the time process B has arrived. Are you able to understand? So process A and process B is there in the ready queue. Okay, meaning is that process A is there in the running queue. But if you look at process A needs one more unit of CPU time to complete its task. So again it will be kept it in the ready queue. Process A is done once. Okay, now process B will be sent to the running queue. It needs totally 6 units of time, but it will be run for 2 units of time because it is a round robin with time quantum 2 units. So process B needs 4 more units. Okay, now if you look at by the time process C has arrived the ready state, so process C will be there, then process B will be scheduled to the ready queue or transferred to the ready queue. Now process A is there, it will be shifted to the running queue. Now what is the remaining burst time? 1 unit. So process A will be run for only 1 unit. You can ask me, sir, time quantum is 2 units, so you should run for 2 units. But if process A is completing in 1 units of time, why should we give 2 units of time? Okay. So process A will complete its task at 5 units of time and it will go to the terminated state. Process A is done. Okay, keep it. Now, if you look at process C is there, it will be shifted to the running queue, and process C need 4 units of time, but time quantum is provided 2 units. We can run it for 2 units and we'll keep it in the ready queue. Now, sorry, look at this one. By the time process D has arrived, then only we can keep the process C. Are you able to understand? Process C is done. Now process B will be come to the running queue because next one is B. Are you able to understand? Process B needs 4 units of time, but time quantum is 2 units, so we'll run for 2 units. And there is no other process to come, so we'll keep the B in the ready queue. And D will be come to the running queue. It needs 2 units of time and time quantum is also 2 units of time. So D will complete its task and go to the terminated state. Process D also done. Process B needs 2 units of time. Process C needs 2 units of time. Are you able to understand? Process D is done. Now process C. Process C will come to the running queue and it needs only 2 units of time and time quantum is also 2 units. So process C will complete at 13 units of time. If you are confused, look at here. Process C, how many times it has run? Only 2 times it has run. 2 into 2 is 4 units. So process C burst time is also 4 units. It is completed task. Process B, 2 times it has run. So 4 units of burst time is done. So its remaining burst time is 2 units. So that's why it is there. So as process C has completed its task, it will not go to the ready queue again. It will be go to the terminated state. So process B is there. Process B will complete its task by 15 units of time because its remaining burst time is 2 units and even time quantum is 2 units. At 15 units of time, process B will complete its task. With this Gantt chart, we can compute the completion time and turnaround time and average turnaround time. Process A, when it has completed at 5 units of time. Process B, 15 units of time. Process C, 13. Process D, 11. Now turnaround time. Turnaround time is completion time minus arrival time. 5 minus 0 is 5. 15 minus 1 is 14. 13 minus 4 is 9. 11 minus 6 is 5. So average turnaround time is equal to 15 plus 14 plus 9 plus 5 by 4, which is equal to 19, 28, 33. Okay, or you can compute like 5 plus 5 is 10, 10 plus 14 is 24, 24 plus 9 is 33. 33 by 4, how much it is? 8 4s are 32. You will have one remainder, which is 1 by 4, 0.25. So round robin you got 8.25. So among them, which has the lowest average turnaround time? This is 7.25, 6.25, 6.75, 6.25, 8.25. SRTF has the lowest average turnaround time for the given question. I hope you have understood how I solved this question. If you still have any doubts related to this question or related to the concepts what I have discussed, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.